Welcome to another video about the result and discussion. This is the chapter number 5 of my thesis. As I explained before that in thesis there are maybe 5 chapters total, maybe 7 chapters, maybe 9 chapters. All theses have 4 chapter commons. The first one is introduction, the second is literature review, the third is materials and methods, and we also call experimental methods. The last chapter is conclusion. You conclude your whole thesis. Between these, this is called result and discussion. Sometimes people make 1 chapter of result discussion. Sometimes people make 2 chapters of result discussion. Sometimes people make 3 chapters of result discussion. It depends on your work. If you have more work, more results and more, you have to discuss it more. If you have less result, you have to just make 1 chapter. So I myself make 7 chapter total. The first 3 chapters are common, the last conclusion is common, but in between I make 3 chapter of result in discussion. So I explained the first chapter of result discussion. This is now the fifth chapter of my result discussion. So basically my work was divided into 3 parts. The first was the nanoparticles. In 4th chapter result discussion I explained nanoparticles. This one is now nanofibers. And the 6th chapter of my result discussion will be the composite of these structures. Okay, so let's go and see. This is chapter 5, result discussion, multiporous tin oxide nanofibers. As I explained, that this introduction just give a brief overview that what are you going to tell the readers in this chapter. It's very simple. You must need to change your tone of language because you have to write this before every chapter, so you have to change the wording. This chapter describes properties of the solution used for electrospinning and characteristics of nanofibers thereby obtained. You see, we just change the language. At the first stage, porous nanofibers and multiporous nanofibers were synthesized. We prepare these nanofibers. Then we characterized mean we did XRD, we did the ACM, we did the TAM, we characterized, and subsequently followed by their testing. When we did this characterization, then we test as a working electrode and dye-sensitized solar cell. You see, it's a very briefly introduction. Just we say again briefly, the multiporous nanofibers resulted in a higher specific surface area. We are telling the readers that the multiporous nanofibers resulted in a high specific surface area, 80 meters square per gram. If you take 1 gram of this material, it will cover 80 meters square area. This area was manifold to that of porous nanofibers. From porous nanofibers, this area was manifold, mean 10 times, 8 times bigger. Expected to incur large amount of dye. If we have more large surface area, it will incur. Incur mean it will load. It will load much amount of dye, and that will lead to a superior photocurrent, because if you have more dye, it will absorb more light and it will generate more electron, and more electron start motion. This is basically current. Okay, so this is, you see, when we characterize, when we synthesize the material at first stage, now we are doing the characterizations. So we make many solutions. We just, where is the solution? We just keep 5 solutions per electrospinning. And just the concentration of that precursor with the viscosity. So this is the first characterizations. And after that, we just find the crystal structure of the anneal samples. When we heated the samples, the polymers left, and just we left with the pure material. Then we just find the crystal structure using XRD. And the XRD peaks give us that it is a pure tin oxide material. XRD was what we want to know, that whether our material is our desired material or not, whether the peaks, whether the material synthesized is the one which we want or not. So when we compare this data with the groups of tin oxide, this is the groups. So the system says that yes, this is the pure tin oxide tetragonal structure. Okay, and this is that XRD graphs here. After that, we just explain the TAM analysis of this material. You can see here, and this is the diffraction pattern of these 2 porous nanofibers and multiporous nanofibers. And just we did the ACM surface analysis of the surface, and here we also did the cross-sectional view of the nanofibers. You can see here, this is the cross-sectional view, and we can see that these are multiporous. You see here, some are single pores, but in some there are many pores here. You see, this is why we call multiporous. This is also multiporous, and some other we call single porous, just porous, we call just porous. So automatically this multiporous has more surface area. So this is better here, you see. And after that, when we finish this, so then we just we also did the gas absorption study. Then we fabricate dye-sensitized solar cell from this material. And the first thing was we just see the thickness of the synthesis of the fabricated electrodes. And you can see here that the material is still porous. This is, you cannot, when you disturb this in sonication and everything, but the porosity is still there. So when we fabricate electrode, it is look like this. And then we just did the diluting and these other characterization. And finally we make a device of solar cell, and we just did this, the current voltage characteristics here, you see. So this is the flow we did, and we also did some charge transport properties, and this is that. And finally we conclude the chapter. How we conclude the chapter? Let's go now. This conclusion is a little bit different than the introduction. In conclusion, while one-dimensional nanostructure routinely produce low surface area, because one-dimensional produce low surface area, and we are not interested in low surface area. Multiporous shows tremendously high surface area. You see, we give the advantage that one-dimensional nanoparticle usually produce less surface area, but we generate something different that is called multiporous, and it has a very high surface area. So in this material, we also maintain the one-dimensional nature of the material and also high surface area. So two advantages thing in our material due to their hollow nature and the presence of multi-channel inside a single fiber. High surface area multiporous absorb large amount of dye molecule and thereby achieve a significant high photocurrent. In addition, multiporous dye-sensitized solar cell exhibits significant superior charge transport properties such as high crystallinity. It was more crystalline. You see here, we know this from XRD. High IPCE, incident photon current efficiency, long diffusion length. Long diffusion length means electron want to have more time, and long lifetime. Then the porous nanofiber counterpart. You see, so we say that the multiporous nanofiber is superior than the porous nanoparticle. Finally, we say that in overall efficiency 4.3 was achieved in multiporous nanofibers, which was while porous nanofiber yielded merely half of it. You see how we change the language here. It's very nice. We can also write here that the efficiency is half. This is, for example, 4.3 efficiency, and we can also write that this is almost 2.1. This efficiency, the porous nanofibers. But we just change this language. You see, they say the overall panel efficiency was achieved using multiporous nanofibers as a photo material, while porous nanofiber yielded efficiency merely half of it. You see, so this is how you can write good sentences. I explained many times that you need to read. Without reading, you cannot have this stage to make sentences in this way. I hope you understand, and if you have any problem writing conclusion or introduction of any chapter, please do not hesitate to contact me. Thanks for watching.